8.6, solving rational equations. Again, rational means fractions. So we're solving equations with fractions, specifically fractions with variables on the bottom. Now, if you look at number 1, the whole deal is going to revolve around let's get a common denominator. So you got to be able to figure out what the common denominator is. In the case of problem number 1, it looks like it's going to be 4r squared. So we want all three denominators to say 4r squared. All I'm going to have to do is multiply the one on the left by 2 over 2. That's going to change that denominator to 4r squared. So what happens is once all of the denominators are 4r squared, we could just multiply both sides by 4r squared, and it completely cancels out that denominator, and we can just look at the top. The top is going to say 2 times 1, or 2, equals 5r minus 25 minus 1. At this point, it's pretty much just a simple solve. Collect your like terms, isolate the variable. So minus 25 minus 1, that makes minus 26. So I'm looking at 2 equals 5r minus 26. Add the 26 over. So 28 equals 5r, and then divide by 5. R equals 28 over 5. Now you could plug that in on a calculator and figure out what decimal that is, or say it goes in 5 times with 3 left, or 5 3/8, 5.6. But your improper fraction is going to be fine. The only thing you have to pay attention to is when it says remember to check for extraneous solutions. When we have variables on the bottom of a fraction, we have this situation that comes up sometimes where your answer produces 0 on the bottom of a fraction, which is no good. All right. So it's good a lot of the times to look at the denominator and say, you know, what's going to make that denominator equal 0? And you should be able to tell pretty quickly that r equals 0 would be bad news. All right. So, you know, before we start, we would know that our answer can't be 0 because that's going to make 0 on the bottom of a fraction. So since this doesn't apply, then I could say that answer is probably right. All right, so checking for extraneous solutions means check to make sure your number is not going to make 0 on the bottom of a fraction. So then number 3 looks pretty much the same thing. Can anybody tell me what I'm going to do? Very good. This middle needs an x over here, so we're going to multiply by x over x because that equals 1, and we're not changing the value. All right, so x over x, and then I know people skip this step, but there's a reason why the denominator cancels out. I'm multiplying both sides by 3x squared to cancel that out. All right, and I'm left with whatever the numerator is. 5x plus 5 equals 1 times x is just x minus 1. When I solve an equation like this, I always like to start with the smaller variable term. So I'm going to subtract x. 4x plus 5 equals negative 1. That's not the only way to do it. That's just the way I like to do it. I'm going to subtract 5. That says 4x equals negative 6. Divide by 4. And x equals negative 6/4. But that reduces to negative 3/2. All right, now check your answer. By checking my answer, all I'm doing is saying, well, let's just, make sure that that number's not going to make 0 on the bottom of a fraction. Well, I know x can't equal 0 because 0 is going to make 0 on the bottom of a fraction. So my number checks out. My number's fine. Negative 3/2, that's okay. Now, number 5 is the first one that's kind of different. All right. It's kind of different because you've got like plus signs in the denominator, like that n plus 3 over there. You're going to want to factor because in order to get that common denominator, you have to look at common factors. You don't look at common pluses. So I won't add a plus 3 over there on the left side. All right, that's not gonna fly. What I have to do is factor the bottom and look at common factors. So specifically the one in the middle has a GCF of n. If I take out n, I've got n plus 3. So you want to look at the factored form and then start thinking about a common denominator. All right. So it turns out that you need an n and an n plus 3. Once you've seen a few of these, you start getting the pattern. But the one on the left side has an n. I'm going to give it an n plus 3, like this. The one on the right side has an n plus 3. I'm going to give it an n like this. Now they're all the same. All three of those fractions have a common denominator of n times n plus 3. All right, and I can multiply both sides by the denominator, but that's just going to have the effect that the denominator cancels out and we just look at the numerator. So on the top, I'm going to distribute this 6 right here, 6n plus 18, plus 1 in the middle, equals 1 times n is n over here on the right side. So, clean up your like terms. Let's see. I've got 6n plus 19 equals n. We want to get the variable on the other side of the number. So I'm going to subtract this 6n just to get the variable on the other side. So that says 19 equals, I noticed some people struggling with this the other day. N minus 6n, remember that is a 1. That's 1n minus 6n. That's going to be minus 5n. At which point, to ISO the variable, you're going to divide by this negative 5. And so n is equal to negative 19 over 5. All right. So when we check our answer, we look at what's going to make the bottom equal 0, the bottom of our fraction. And so right here, we can see negative 3 is going to make 0. And right here, we see 0 is going to make 0. There are two numbers in this problem which are not allowed. We can't have our answer be either one of those two numbers, but it's not, so I'm good. All right, as long as if you solved it out and you got your answer n equals negative 3, that'd be a problem. You'd cross it out and say no solution. All right, so number 7. Again, it looks like a big old mess, but if you factor the bottom, it's not going to be so hard, okay? So we look at the bottom, and over there on the right side, I see an easy trinomial. You need to come up with two numbers and multiply to negative 32 and add up to 4. So maybe you already know this. Looks like it's going to be 8 and 4. Multiply to negative, add up to positive. I think it's negative 4 and positive 8. And that's good because if you look at the other fractions, you've already got an n minus 4 and an n plus 8. So it's consistent here. Okay. The one on the left has an n minus 4. Let's give it an n plus 8. The one in the middle has n plus 8. Let's give it n minus 4. Like that. Okay. Try to write neatly. I know you don't have a whole lot of space. Write small, write neat. But the whole ball game is if we can get those denominators the same. If we can get those denominators the same, then we can multiply both sides of the equation by that denominator, and it's going to cancel out the denominator, and I don't have to look at it anymore. All right. So I just need to clean up the top. Distributing this 1, we'd have n plus 8 equals, distribute this 8, we'd have 8n minus 32. And then notice this is minus 1 right there, minus 1. Okay? They're all kind of the same at this point. You just need to isolate the variable. Collect your like terms, isolate the variable. So we have n plus 8 equals 8n minus 33. I'm going to subtract this in. Doesn't matter. There's more than one way to do this. I have 8 equals 7n. Again, remember, that's a 1 right there. 8n minus 1n is 7n minus 33. Add the 33. 8 plus 33 is 41. Let's move over since I'm out of room. 41 equals 7n. We can divide by that 7. N equals 41 over 7. I think, let's just check and see what's not allowed. Can you see what numbers are not allowed? Positive 4 and negative 8 are not allowed, all right? We can't have the answer be either one of those two things, because if they were, that would make 0 on the bottom of a fraction. That's going to be undefined. You're going to get an error. That doesn't really happen here, so I'm all good. All right, this last one? All right, last one. You're not going to add on a minus 8x. That's not how it works. You can only give it a common factor. So better factor first. I see a GCF of x. Take out GCF of x, you have x minus 8. Over here, it's the same thing. You've got an x of the GCF and an x minus 8. Once you get to this point, it should be obvious to you that the middle one is going to need an x minus 8. So once we give it x minus 8 and the denominators are the same, we can multiply both sides by that denominator and it wipes it out. So let's just look at the top then. I have 8 equals, distribute the 1, and so that's going to be x minus 8, and then minus the 1 there at the end. Is that it? 8 equals x minus 9, add 9, x equals 17. Good. We check the answer, and 0 and positive 8 are bad numbers. Those can't be, those aren't allowed. But 17 is just fine. Yeah, if you would happen to get, like, if you solved it out and you got x equals 8, you would say, ooh, I can't do that. And so you would cross it out and say no solution. Okay? But that doesn't happen here. But it could. It totally could.